Wow, fun crowd. Fun crowd. No, the crowd is clearly self-selected, so. Yep. Test. Yeah, we should be here. I'll talk over it rather than into it. Or I can just spike the lav and then you can rip your headphones out of your ears. All right. Yeah, I think we'll get started here momentarily. Most of you probably know me already, at a minimum because I was on the podium earlier today. So the BOF and the plenary topic were sort of independently proposed, but they kind of fit nicely together. So the PC and their infinite wisdom approved both of them. And so we had, a nice debate with fireworks this morning. I think that's fine. So far, what we got is the proposal for the BOF topic came about because of a thread that I saw on the NANOG mailing list. Back in December, Frank Martin wrote, I just had a personal email from a brand new ISP in the Asia Pacific area, desperately looking for enough IPv4 to be able to run their business the way they would like. This is just a data point. That kind of stuck with me because from my vantage point, well, yes, obviously Frank is a troll, and but so are lots of other people on that list. Right. And obviously that thread was sort of calculated to produce more heat than light. That said, if there's enough smoke, there's probably a fire underneath it somewhere. And so apologies to Frank Martin notwithstanding, I found the post and the resulting thread actually kind of interesting. From my vantage point, I didn't really have as much IPv4 as I wanted back in the mid-90s, and it's unlikely that I'll ever see that much again. And certainly, I'm going to have to continue to run the services that I provide on an IPv4 network with proportionally fewer addresses in the future because I actually expect that business to grow, or at least I hope it's going in the right direction. So notwithstanding anything that we do with IPv6, we're going to have to support IPv4 for the while. And in the absence of registries that can deliver more address space to us on the basis of need, we're either going to have to do more with less address space proportionally, or we're going to have to meet those needs in other fashions. And so I rounded up some speakers to address that. In keeping with the consistency of the NANOG community, there's a lot of people represented here. So we have network equipment vendors, transit network operators, internet content providers, and IPv4 address brokers. And given that we only have 4 speakers, I think that was actually a fairly good distribution. The other key participant in this whole thing is you guys out there. So there are essentially 4 presentations that frame various portions of this problem space, but there's 90 minutes. And so the things that you bring to the table are at least as valuable as anything the speakers have to say. So keep that in mind. Agenda-wise, I think this is the order we're going to use. So Fred Baker, then Randy Bush, Charles Lee, myself, and open microphone. Please avail yourself of the microphone. A BOF is a dialogue and not a lecture. And if you have a topic that you want surfaced, please bring it to the mic and inject it either when it seems most appropriate or in the open mic, which is basically a free fire zone at that point. So that's what we have. And I think Fred is going to speak without the accompaniment of slides. So I'm just going to let him rip.
Okay.
And you want to use the lab here?
Sure. So actually, I decided I would bring some slides. So,
Okay.
so here I am. One of those sides. It's either one or the other. Yeah. Okay. So where I'm coming from right now, if you want to service a vendor viewpoint, hey, whatever you guys want to buy, we'll sell you. Okay. But coming from a different perspective, now I'm looking at proposals going through the IETF. Oh, there we go. And things like Joel just mentioned Frank Martin's famous email. And this is actually pretty much the scenario that Frank is facing. He's looking at a network that is going to have to provide IPv6 capable services simply because that's the only address space they've got. They've got a very small amount from APNIC, and they're going to be buying addresses for the rest of it. And as a result, they're going to be pretty deeply into some variation on carrier-grade NAT, and very, very quickly. In the IETF, in Joel and my working group, we've seen 4 different proposals that, to my mind, look something like this. I take, on the left side of the screen, I've got some number of users that I decide are never going to deliver client services. And I say, fine, I'm going to put them in 10 space and bury that inside a V6 prefix and let V6 be used to differentiate among them. It essentially becomes an extension of the address and with NATs at those boundaries. And then as you go into a data center, there's going to be some sort of a translation there. Ideally, that would be literally a V6 data center and be able to keep track of user identities and locations and that sort of thing. But what Chinatel is talking about, which is where I got this slide, is actually translating back into V4, which has some issues in terms of losing identities and geolocation and all that kind of thing. And why do I call it my nightmare? Well, because of the implications for the implications for the growth of the network in terms of new applications. I've got a whole bunch of people that really can't talk to each other because they can't address each other. But you know, as I look at this, this actually is a viable way if you have client-only services, and many residential networks are in fact client-only services. This does become a way of multiplexing your address space in a way that doesn't require port sharing, doesn't require all the issues in port sharing, actually does let you identify a subscriber, and takes you therefore into an ability to keep that business running. So that's kind of the thoughts that I had there.
Thank you. You can actually click with the mouse, because then the wheel rolls.
Okay. So, yeah. Okay. I'll survive. Okay, on this actually a talk I gave at the IGF. So why the solution to IPv4 runout is not more talking. It's moved to IPv6. But why has this been so disgustingly slow? Was the fault the vendors, you know? Was it the lazy operators, as the IPv6 idealists have said? We just wouldn't move to IPv6. Was it the lack of content in IPv6? Is it that applications don't support IPv6? Is it the CPE? Is it the end user host stack, all those silly little Windows 95 machines? Is it because there are only 430 transition mechanisms? Transition depended on all of those at the same time. This was a recipe for failure. But there's one much larger problem, okay? And that is IPv6 is on the wire incompatible with IPv4, right? So it had a new business model. Those of us who were old enough to remember TLAs and MLAs, there were only going to be 4,000 ISPs allowed, right? It was just drugs, okay? And no feature parity with IPv4. We're still fighting to get DHCP v6 router announcements. We're still fighting to get parity, okay? It wasn't a transition, it was a goddamn leap. How did this happen? Arrogance and operational cluelessness in the ITF. Major embarrassing stupidity, okay? IPv6 is incompatible with IPv4, and there was no realistic plan. Oh, they're just going to run dual stack everywhere instantly, right? So, but it's not too late. But it is too late to screw with it. We don't have an alternative, and it would take years to do it, and we're out of v4 space. Okay? So, the IPv4 internet was a simple place. Okay, packets flowed freely between us. Everything was cool. Okay? We can easily destroy this. Fred had a nice slide on destroying it. This is mine.
Blaming you. There's a reason I call it a nightmare.
Pardon?
There's a reason I call mine a nightmare.
Yeah. Well, I just do it differently. That's the Grand Coulee Dam, by the way. There's one serious problem with the CGNs, though. We're the salmon. And we can't make it. It's just going to be hell. Okay? And when those people say service continuity, what they mean is they're not transitioning to v6. v4 forever. Okay? v4 life support is what they call it. Okay? And that guy is not feeling very well, I assure you, except that is we. Okay? And they're not going to remove the Grand Coulee Dam, and those carriers are not going to remove the multi-million-dollar CGNs. Okay? End-to-end principle, the stupid core and the smart edge, this is what the internet is. This is why the internet works. Okay? The smart edge and the stupid core is, you know, voice had the stupid edge, those silly little phones, and very smart, expensive core. These monstrous switches with everything built in. The internet's the converse. when you start putting CGNs in the core, when you start making the core smart, when I want to deploy a new protocol, Skype 2 or whatever, I can't do it without AT&T and Comcast lawyers' approval. Well, you think you're going to get that for something that competes with their core product? Fat chance. But on-the-wire incompatibility means really transition has no choice but encapsulation or translation. Okay? So, this is a partial map of the toys with which we're supposed to do this. Notice that this way is green, that way is red. Stateful bad, stateless good. Stateless scales. Stateful does not scale. IPv4 over v6 scales better than IPv6 over v4. Okay? So, this is really the space. This slide, by the way, credit to Mark Townsley, Oli Troon, etc., and Dan Wing, stolen from them. So those are the technologies that, will get you more longevity, will get you better scaling, and will get the user better. Jeff, come on, speak up.
Well, they won't get you more longevity because in general the stateless ones consume more V4 because you've got to sacrifice something. It's not a...
Well, it consumes more something. A lot of those are essentially A plus P derivatives, and they get the, quote, more V4 by stealing address bits from other pieces of the IPv4 header.
The DIVI, for example, is one-to-one match between...
Right. IBIs, correct. Some of them work better than others, as it says.
Well, I'm trying to say that nothing comes for free in all that.
Nothing comes for free anyway. I mean,
Yeah.
Period. Okey-doke. Stateful versus stateless tunneling. Okay, here's some contrast feature by feature, mapping, scaling, control protocol needed, no control protocol needed. The address systems remain independent versus they're coupled by algorithm. Stateless is essentially saying there's an algorithm to do this versus it has to be configured. Okay? So, work on mechanisms which are actually progress towards V6. Prefer mechanisms which are simple and stateless. Use IPv6 when you can, not IPv4. Keep state at the edge, not at the core. Push it to the CPE. Use mechanisms which preserve end-to-end and motherhood and apple pie and all those wonderful things. Okay? Tunnel if you have to. Translate only if you are desperate. Okay? And tunnel over V6 if you can. That's it. Thanks, Joel.
That's enough.
Pardon?
That's enough. That's enough.
There ain't no free magic. Focus on.
Yeah. Masata Kota from Tokyo Institute of Technology. Can you push back to your figure with dam?
My what?
With figure with dam.
Yes,
Yeah.
slightly incorrect.
Yeah, and the most straightforward solution is to remove dam. And the water level becomes 48 bit with A plus P. Yeah.
Takes a lot of dynamite to remove that dam.
Oh, yeah. Perhaps we have to
Maybe you
destroy
don't- maybe you
ITF.
could not build the dam.
Well, yeah.
Yeah.
Don't
Don't
build
build that. And another point is that you say stateful and stateless, but that I think is not a proper distinction. Instead, NAT should be static, not at least not very dynamic. Then you don't have to log alert. and you don't have to have much performance to do everything dynamic.
Well, if NATs are static, then you've got a directly mapped inside address to an outside address.
Pardon?
If NATs are static, you have a directly mapped inside address to outside address, right?
Yeah.
Otherwise, they have to be dynamic.
So then end host needs configuration, but configuration information can be obtained from NAT box through PCP or something like that. And the end users don't have to configure end boxes by themselves. It's like DHCP, using DHCP. And if NAT is static, and there is some auto configuration mechanism, stateful NAT is fine.
So I think one of the cases that stateless NAT translation actually works rather well is in the context of going from V4 to V6, because obviously on the V6 side you can have as many identifiers as you'd like for the V4 addresses that you have inside your network. So that's, I think, a particularly good case where expansion actually works the other way around. Of course, you're never going to have enough identifiers packed in anything. So.
Well, yeah. So going back to the first slide that I showed, where you had the IPv4 address in, it's called Nightmare, where you have the IPv4 address in the EID of an IPv6 prefix. Then basically per prefix you've got instances of the V4 addresses. And the problem becomes on the other side, where you try to translate that into IPv4 again, talking to some remote device, because now it loses its sense of identity. So the third slide, actually.
So that one.
Yeah. So this actually accomplishes what you just said, but you still lose information on the server side of the thing.
Oh, that's highly nice. Something. Yeah. Oh, anyway.
I'd make a comment about my computer working because it's a Mac.
Yeah, well, we have two versions, we have the awesome PowerPoint here. So, Charles, you want to take it away?
So,
see if we can do it.
Doing more with less. And people would think, why are you talking there when my business is basically about doing more with more? Well, we don't think that markets are the complete solution. There is no silver bullet. The situation that we collectively find ourselves in will require multiple solutions all happening at the same time in order to buy time for all the component parts and challenges to be resolved. It's going to take some time. Now, I was asked to address this group about some basic stuff about markets, really basic stuff. So, this might be really boring for you. I'll get through it as quickly as possible. Why is there a marketplace? Well, I think most people know it, but it's kind of helpful to refresh. Global exhaust, quote unquote, has occurred in Asia, is occurring in right, depending on the pace of allocation, will occur in other places at other times. It is not a uniform situation on a global basis. But the demand for IP numbers is growing, and that growth is being expressed everywhere. And those demands come in all kinds of sizes and shapes. There's new market entrants, there's emerging regional participants, there's incumbent business proliferation, and there's internet device proliferation everywhere. Wireless mobile devices are the place where most people see the point most easily. If you look at the global deployment plans for 3G and 4G mobile services, you see that there's about 10 billion subscribers to those services today. And that's interesting because it's larger than the population of the planet. But it is forecast to double, which is even more interesting. So apparently we're all going to have 4 or 5 of these things. But there's no near-term viable technical alternative for a lot of providers. It just isn't there yet. And so we have this near-term challenge. And as was pointed out, 6 is not an extension, it's an alternative. So effectively, we're creating 2 internets, the V6 internet and the V4 internet, and those 2 things are islands unless we solve a lot of technical challenges to integrate them and to make it a seamless experience for the end user. So we do know that there are lots of very smart people and major corporations addressing these challenges. When all those challenges get met, I leave to others to predict. My crystal ball is not quite that clear. So what do service providers need? They need a complete solution to getting the number blocks that they need. Now, I use numbers, but you must understand that markets will deal in number blocks, not numbers. Individual numbers are not going to get bought and sold. We're talking about number blocks, and there's some interesting challenges about doing really small blocks. There's a lot of fear and uncertainty about disaggregation, which might occur in an open market. I would observe that disaggregation is not a natural consequence of a market. It may be a natural consequence given a protracted period of scarcity, but it certainly isn't occurring right now. So what's a marketplace got to provide a buyer? It's got to be trusted, it's got to be fair, it's got to be unbiased, it's got to have a consistent set of rules that are uniformly applied, it's got to be secure. People need guidance, truly expert guidance on what it is they're buying. They need access to an extensive inventory of blocks. They need tools to assist in evaluating and assessing the value to them of these number blocks so that they can make an informed business decision about acquisition. And they need complete transaction support. As I said, pretty vanilla stuff. Most people know it, but it's really helpful if it's presented. And what does an effective broker do? So sellers need brokers. Why do sellers need brokers? Well, they got to get some asset analysis done. You'd be surprised how many sellers don't have a clue. Their ownership or other rights need to be researched and documented. They need sales strategy advice. They need preparation, packaging. They need a standard set of transfer asset sale agreements so a marketplace can behave effectively. They need to maximize the competition, and they need that complete transaction support. So the pieces that are really important in there that most people would overlook have to do with the ownership rights and research and documentation. I'll talk about that in a bit. I was asked to convey what are the standard steps. Well, I can only speak for us. So, timelines and what might expect. You've got to do your certification work. It's 2 to 3 weeks on average. Some cases, much, much worse. If you're going to California to find a public record out of the courts, it's 90 days for delivery of that document to occur. If you're in Delaware, you can probably get it overnight. If you're in Sri Lanka, maybe never. So it depends. You've got to get it packaged. And packaging is not as trivial as one might think. You've got to put it in a form and a format so a buyer knows what he's getting, when he's getting it, at what price point, etc. You got to do marketing. You got to conduct your competition. You got to execute the buyer. You got to go through escrow. There's a lot of steps that are necessary. So the meat of the matter. There are 2 broad categories of number blocks out there, and they are service contracts. These are ones which were allocated by an RIR and are encumbered with the service contract constraints. And I'll get to that in a bit as to what those may be. The other major category would be assets which were allocated absent the service contract. These 2 are fundamentally different types of number blocks. They share certain attributes. Both of them are vast. There's vast numbers in both groups. Minor fractions are actually being used. Let me let that sink in for a minute. A minor fraction of both of those categories are actually being used. That's not to say that they're actually being advertised. It's how many are actually being used. There are a lot of companies which, for various reasons, advertise address space and don't actually use it. Some do it as a preventative measure to keep other people from squatting on it. Some people do it because they're lazy. Some people do it because they didn't know what else to do. There's all kinds of reasons. But each of those major categories has the capacity to fuel the continued growth of the Internet. In my case, I'm talking about the Internet as IPv4 Internet. So the service contracts, they're fluid, and they're really tough to explain. There's rights of use versus rights of ownership. As I said this morning, that was unilaterally decided by the regional Internet registries around the summer of 2003, when magically the contract said you do not have any property rights. But what it does say is you have a right to use. Terrific. That's a different thing. It has a different market value. The 5 RIRs enact self-interest policies, as they should. This is not a condemnation. This is good. That's what they're there to do. And their policies and processes are structurally similar, but the differences make all the difference, in particular the timing and the means by which these decisions get made. So service contracts can be sold, but the value to a particular buyer is dramatically lower. They can be transferred, but only with the approval of the RIR that issued the service contract. And that complicates the transaction because you have this third party that's in the middle of the transaction between the buyer and the seller. And it introduces risk. Will they, in fact, end up with the contract services or not? The inter-RIRs transfers, that's region A to B, are possible, theoretically, but now you have two independent actors, independent third parties to the transaction. So it's two moving targets that have to be hit because both are changing their policies and processes independent of each other. And then the whole thing is seemingly designed to strangle traditional business practice. Now, again, I don't think that was intentional. It's just a construct of the way things are. Ownership rights and associated value to the buyer get shredded, and needs assessment harms the value to the seller. You put the two together, and you have a frustration of a market. On the asset side, there are challenges in that category as well. First of all, there are fraudulent allocations. We do a lot of research, and we have a lot of people that come to us as interested sellers. And we will not present one of those number blocks into the marketplace until we definitively know that the seller has the right to transfer it. So the first thing we do is we require this certification, this process that says it's really yours to sell. First up, of course, is allocation. And there were material misrepresentations made at the time of allocation. To us, that's poisonous. That means that they never got it appropriately to begin with. And if you didn't get it appropriately to begin with, it's difficult to defend that you have the right to transfer it later. So material misrepresentation, unfortunately, is not as rare as one might hope. We have discovered that control does not equal ownership. Breathtaking overreaching occurs. There are entities which have had control of an internet block for the last 10 years, but this does not make it theirs to sell. I use the analogy that somewhere there is a guy driving around with my car radio. That doesn't mean it's his. He has control and he has use, but it's not his. It's mine, and I'd like it back. And if I ever found out he was trying to sell it, I might contest that sale and drag everybody to court. Then we find out that use is neither control nor ownership. And misappropriation is not that uncommon. The most common example here would be spammers who like to jump into number space and use it and then jump back out of it. They tend to pollute the environment behind them because the number block of the poor asset holder has been polluted and put on a blacklist somewhere, which has got to be sanitized and cleaned back up again before a buyer can even consider taking the block. And when I discovered that and discovered that there were approximately 130 independent blacklist operators, I discovered that there wasn't a central control mechanism in that process anywhere, and it could take a long, long time to, quote, clean a block. But it's necessary. It has to be done. And then gray status. 30 years of record neglect can create a hairball that's just too nasty to touch. There are original allocations made way back originally, late 80s through the 90s and so on. And these companies have come and gone. They have been merged. They have been transformed. They have changed their name. They have moved offshore. There's all kinds of circumstance which has to be documented into the middle of it. And most of that documentation is absent, because at no point along that history did anyone consider that number blocks might be worth something somewhere, so they were traditionally not referenced at all in a merger and acquisition. At that point, you have to decide, how do I go about determining who got it? When I find a company that bought the assets and operational components for a network from company A, and they don't mention the IPv4 number blocks anywhere in the documentation of assets that are transferred in the acquisition, can I rightfully assume that they got it as part of that transaction, or can I rightfully assume that they retain the ownership? So there's some tough calls that have to get made here. And then, most challenging, it turned out that the Who-Has records were neither reliable nor authoritative, and didn't even give a good place to begin the process. And that has gotten geometrically worse over the last 2 years. There are somewhere, or I checked before I came in, there's somewhere around 35,000 fraudulent records out there that I'm aware of. Now, there's a long way to go before I can give you a complete answer, but for security and stability issues alone, that should be quite terrifying to all of us. I've been asked to talk about Nortel. There's a couple of hidden truths in that transaction. One was Nortel sold the exclusive right to 38 number blocks, an unfortunate 666,000 numbers. 666 was probably not the ideal number to begin the transaction market with. None of those blocks were in the Aaron Who-Has databases belonging to Nortel Networks. That's not to pick on Aaron. It just happens that that's the database where they would have resided. So 38 out of 38, what were the odds that I got the only 38 were wrong? Pretty bad. Turns out there was a lot more that are wrong. But it took hundreds of man-hours, literally hundreds of lawyer man-hours, and 2,600 pages of documentation to tie those number blocks to Nortel Networks. It was only after we had done that that the court ruled they were Nortel's to sell. So extraordinary effort just in certifying that the seller had the right to the number blocks and was the right entity to engage in the transaction. On the buyer side, the asset owner had the exclusive right to sale. The court approval, and it's a quote, "The sale of internet numbers free and clear of all liens, claims, encumbrances, and interests." This was the title to the definitive finding of the court. So the court said, yep, they are Nortel's to sell, and of course this made Microsoft quite happy because it meant they were Microsoft's to buy. There was zero legal requirement for anyone to enter an agreement with a third party prior to a sale, and no third party approval of the sale was required. That's just the way it was. So the court didn't view policy processes as binding on the court. They used the law, and they use asset law and property law as the milestone. $64 million question, particularly if you need numbers, what are they worth? I can't predict that. Competition is the key. The more competitors in a market, the more desire that's there, the greater the demand, the higher the price the seller can expect. Block size does matter. Bigger is usually better. Now, having said that, small blocks have the single highest price per number out there. But the transaction costs of doing it consume any benefit for disaggregation. There is no financial incentive for disaggregation. None. It's quite the contrary. So those of you that are concerned that a market would incent disaggregation, no. The numbers don't bear it out. But /24s are really pricey, and the reason is there's so many people that need them. And as a consequence, they drive the relative price of those quite high. validation and determination of legal status absolutely matters. It's essential to any potential buyer. No buyer, no rational buyer, is going to buy something until they know it's the seller's to sell. It is hugely complicated and expensive. That is a cost that we incur getting it done. We ask the seller to pony up part of it. The seller gets a fixed cost and no guaranteed return. What they get is $10,000 bill for the process. I spend a lot more. I basically lose money on these. But I can't take it to a market until I know it's his to sell. And if he's not willing to pony up a little money to prove it's his, that's pretty much a red flag to me that perhaps it's not. Now, we can defer those payments, but the obligation is incurred. And competition matters. Regionally constrained competition lowers the value to all parties. A number block that can only be used in a particular region is worth less than a number block that can be used everywhere. Makes sense, right? And global competition between highly motivated, financially strong entities maximizes the value of the asset. Again, motherhood and apple pie. If you have global competition and you have entities that are financially strong and they're competing for these assets, they're doing so for a single purpose. They intend to make money with the number block. They're not buying them to put them in a shelf. They're buying them to put them into the market. And that's good. Thank you. I'm available. Try the deal. Charles.lee@adrex.net, and I'll stick around after the panel. Hope it was helpful.
I'm almost certain there's somebody who wants to come to the microphone.
No one?
Nobody? Come on. Oli?
Ole Jacobson at Cisco. Out of curiosity, if they weren't registered in Aaron's database to Nortel, who were they registered to?
They started with companies like Synoptics. There were all kinds of different companies that were acquired.
Companies Nortel had purchased.
Synoptics, Wellfleet, Bay Networks.
Right.
You can probably go down the list.
Right.
Northern Telecom.
No.
Well, yeah, maybe not. That
Actually,
probably
no.
went to Bell, the Bell system, didn't it?
That's still tangled up in Canada over ownership rights of who actually owns it.
Right.
It's still there. It hasn't been resolved, and while you have two competing debtor interests, I'm not sure when it'll get resolved.
No way, eh?
No way, eh?
Yeah. More mics?
Matt Petak, Yahoo, sorry, I'm here. On your last point, before you run away from the slide deck there, you were talking about how global competition between
Financially strong, well-motivated, yep.
Yeah, good,
Yeah.
good quote there.
Yeah.
You made kind of a last comment that people aren't buying these to put them on the shelf.
No.
They're buying them to use them.
Yes.
There's still, though, the possibility of speculation. There is still the possibility of people buying them to use them not as IP resources, but as a financial vehicle to say, hey, I bought these, I anticipate the value of them going up with increasing scarcity. The more I buy, the higher the overall price of the remaining pile for the few people, basically speculators.
Yeah.
Are you claiming then that somehow this global competition is going to prevent speculation from happening?
No.
Do you view speculation as a good thing for IP addresses?
No. What I'm suggesting is that it's difficult for a speculator. It's really a difficult business challenge. Believe me, I've talked to a lot of companies, and I love talking to all of them. I've talked to banks. I've talked to investment houses, people that might be interested in speculating in a market, and have the financial wherewithal to do just that.
And none have said, wow, IP addresses are the next big thing to buy into?
Well, they all start with, wow, that looks really interesting. And then the business case issues start coming to bear. And for them, as a speculator, The business case is really challenging because there's no definitive end date. This scares them tremendously. So it goes up, it goes up, it goes up, it goes to 0. Aha. When? Don't know. When some smart person finally figures out how to make V6 and V4 compatible, when gateway services are finally in place, when it's cheaper to deploy V6 versus deploying V4.
It's unlikely it would be a flag day go to 0 minus
There will
0,
be
but
0 flag days, that we know. But it also occurs on a regional basis, and this is a point that was made at the earlier panel by Mr. Huston. I hope I'm pronouncing that right.
Houston.
Houston.
Okay, thank you. The challenge here is it's not going to happen uniformly. It's going to happen in very specific geographies at different paces. That's a consequence of the allocation process that we had nothing to do with. But what has happened is you end up with certain parts of the planet that are having to deal with absolute scarcity before other parts of the planet are even dealing with it on a theoretical basis. And so, they're going to create solutions in those spaces which may be market-based, which may be carrier-grade NAT, which may be who knows what, and it will be a hybrid of all of them, is my prediction. But do I think speculation in the market is a good thing? No, not really.
But it could happen. But
It's
you're saying
possible.
the market forces would keep it from being widespread and exerting a large-scale control
Agreed.
of the market.
But,
Okay.
but more importantly, until there's a defined market for free exchange and there's lots of liquidity in that market, people aren't going to make that bet. Right now, I'll tell you definitively, the only people that are interested in acquiring number blocks through a marketplace have a business need. And that business need is all based on an ROI. It's all about getting into this market, and it's all about the business they could do as a consequence. They can buy routers, they can buy fiber, they can buy all this good stuff. But without a number block, they don't have a business.
Thank you.
Yeah.
Go ahead.
Zaid Ali from LinkedIn. So earlier on you mentioned that, it's a pretty, you said something like $10,000 that you charge, and, but the whole process, is cumbersome, it takes forever, and you can't like find information, all that. Shouldn't you really just get out of this business?
No. Just because something is hard doesn't mean it's not worth doing. I believe, and I think a lot of people here would believe, that an absolute authoritative record of who has a number block would be a very useful thing. I don't believe it is a good thing that vast numbers of number blocks are unattributable, and we really don't know where to go if we have a problem with it, if somebody's poaching on it, if somebody starts doing something illegal with it, if it's, just fallow, dead. That's another circumstance I've come up with, number blocks where the owner is dead. What do you do about that? It is now the property of the state. Just because things are hard doesn't mean they shouldn't be done. And I genuinely believe, that knowing definitively who has the rights of exclusivity to a number block, to use, to not use, whatever they choose to do with it, is a good thing and worth doing.
So one more question. So you mentioned about spammers earlier on, right?
Yeah.
What do you guys do in order to sort of vet people that come up and buy IP blocks? What's your responsibility?
We do a lot to vet both sides of the equation.
Like what?
So I was going to share.
Yeah.
All right. So one of the things we do is we maintain the do not trade lists, all the bad actors that are listed. We subscribe to, I think it's 36 separate databases. So, we don't engage in a transaction with North Korea. North Korea is not going to be buying a number block. I'm just not going to sign a contract with them. We also take the next step and we look at what are the business practices of these entities, and we make sure that they're not doing something which is bad. Now, spamming is against the law. If I knowingly put a number block into their hands, I'm facilitating them breaking the law. That's not a good thing. Now, if I do it unknowingly, they've misrepresented who they are, I can't protect against that. But if they knowingly, if they identify who they are, and we figure out that they're doing something that's both illegal or otherwise questionable, we just don't allow them to participate in the marketplace. Because we're private, we can do that. If we were public, we would have a problem. But because we're private, we can make those decisions. And we won't do it. We just won't do it.
Interesting.
Andy?
Andy Anshev, A10 Networks. A couple of questions. First is, it sounds like financial institutions could choose to enter the market if they wanted and start to buy blocks up. Is it accurate?
They could.
Okay. So if you follow the financial press, you'll see that there are some instances where people will take speculative risks.
Mhm.
They'll buy Greek bonds. They'll do various other
Oh,
things
yeah.
that have some sort of
Yeah.
end date to their value, right?
Mhm.
So I don't see how this is really different than that scenario.
Well, it's not materially different because there are entities which will take extraordinary risk for what they view to be an extraordinary reward.
Yeah.
There's not an extraordinary reward associated with number blocks that's foreseeable. This is one of the great myths that's out there. Everyone seems to think that an IP number block is going to be worth, $1,000 per number. No, it's not. It's not going to be there because there's economic alternatives. You're not going to get there. Right? It's just not going to happen. So is there value to be made in buying and selling number blocks? Yes. Is there enough to attract somebody that would do it as purely speculative? Probably not.
Okay.
There'd have to be like a 2-to-1, 3-to-1.
Yeah.
And fairly
Yeah.
So a question for Randy in terms of the Frank Martin email. What would your advice be to Frank?
Frank was a troll.
Does he mean that literally?
Yeah.
But the scenario can be real, though.
The Asia Pacific ISP, which says that they need to enter the business. First of all, one of the two reasons I served for a number of years as the co-chair of the APNIC policy suite was to nurture a policy through which took the last /8 and said the policy for the last /8 is to chop it into into the current, then current, or to the current at any moment minimum allocation size, and only allocate that. One per customer, no repeats. So that meant that, and still means that for a very long time, a new entrant can get a block.
Yeah, so
Well, and they did get a block.
yeah.
We don't know whether that
W- w-
people Mark Frank was trolling about, if they existed, got a block or not.
Right.
Well, he gave me the name of the outfit and said what size block they got.
Yeah.
The second thing is he said they couldn't get what they wanted. So the answer to that is welcome to life.
Right. So, I mean, that's an interesting exercise here. If you were expecting to get what you would have gotten in 1998, well, you're not going to get it. And that goes back to the title of this exercise, which is doing more with less. The fact of the matter is like new economic activity is going to be engaged in, and it's going to need IPv4 addresses, and it's going to use them more efficiently than it did previously. It depends on what you define as efficiency in this case, but it's going to use more addresses proportionally for the same amount of economic activity. Fewer addresses proportionally.
Answer do more with more. Use IPv6.
Right.
Right? And so part of the reason to get that little piece for the front of your network of is so you can have a V6 network behind it, and just when you still need access to some V4, you don't need.
So what mechanism would I use to support all of my customers out there who have V4 devices, in the infrastructure? Any particular one you like or favor?
Yeah.
4RD?
Yeah.
Uh-huh. Okay.
So if you look on the quadrant slide, there are a number of choices. Some of them are clearly worse than others. I think Randy would probably recommend that you not pick the really bad ones. Some of them. Right. Randy believes that his competitors should choose the really bad ones. Oda-san?
Yeah. As for price of an address, how do you think about removing a well-known address? With well-known address, you can't have more than 2 web servers for an IP address unless you attach explicit port number into URL. But there is a mechanism in DNS to make it unnecessary. And how do you think about deploying or developing such a technology extensively?
So you're advocating the extensive use of SRV records.
Yeah.
Okay. I think that's an interesting premise. There are some pretty good examples of the use of SRV records. I am suspicious that they actually will get used more in the future than they are now. I mean, that actually seems highly likely.
Yeah, and I wrote an internet draft to use SRV with URLs in general.
Yeah, I'm inclined to agree with you. Okay, so last presentation that's actually on the agenda. We have about 30 minutes before we can all go drink beer and fall over routers. So this is a look at a rather narrow problem space within the sort of internet content provider space, and I picked this out because it's something that I've been interested in for a little while. The disclaimer, I would say, because our legal department would ask me to do this, these are my opinions. They are not the opinions of my employer, nor for that matter are they the operational practices of my employer, and I've been doing this for a little while, so I think I can have my own opinion. Internet content providers do not, in my direct experience, naturally soak up as many IPv4 addresses as consumer-facing ISPs in proportion to the size of the customer base. So if I have to allocate IPs to customers, I'm going to soak them up in some proportion that's much closer to the number of customers I actually have. However, on the content provider side, scale drives address consumption. State accumulates in uncomfortable places, and that actually drives address consumption. And the default position today for new entrants, if you go to a bunch of venture capitalists and say, I have this idea for a service, they're going to say, this is awesome, let's build it in the cloud, right? Because why am I spending capital that is mine on you building infrastructure? So one of the things that means immediately is if you're a new entrant in this marketplace, you're not automatically building a network and going to Erin, which means if you are building one of these things now, in 2 years, when you need addresses because you need to step outside your single cloud provider or your multiple cloud providers, you may be in a different position than new entrants to this market are in today, or were 2 years ago or 5 years ago when they were getting funded. Then, much like outgrowing a provider assigned assignment or having to renumber, moving out of the cloud can be an uncomfortable position to be in, especially because you have no pre-existing resource or, in fact, say, experience actually operating your own data center, network, IP numbering scheme, stateful devices, or anything. So that can be a challenge. To harp on a point that I brought up in my previous talk, 30 to 40% of the prefix assignment requests in a given year in the ARIN region are the first request from that entity. Those entities get between 1.5% and 4% of the address space assigned in a given year. So 40% of the people getting 4% of the address space. Sounds like a movement we've heard about in the United States here. The rest of the address space, the other 96% of it, going to existing holders, going back to the well. Part of that is because those people have the growth of their business as an engine for, requires address consumption. The other part of it is simply that they are acquainted with the process and they are used to consuming addresses in proportion to their needs. So new entrants to this marketplace tend to come in a lot more conservative.
What percentage, how many consume that 60%, 70%?
So 60% of the requests in a given year are from existing resource holders.
I have to know the answer to my question. 10, absolute number, not relative.
Yeah.
10 current holders get 75% of the address.
Correct. The distribution here,
Called an open, easy market.
right. The distribution is composed of giants and dwarves. There are a very small number of giants who account for most of the address consumption in the ARIN region. There are a very large number of dwarves who represent a tiny portion of the address consumption.
This is an actual outcome.
Absolutely. I'm saying nothing about the fairness of that exercise. These people...
Probably approximates the fairness of the open market.
well...
Those who can afford it, those who can't.
Yeah, that's possible. So while everyone dependent on the availability of more IPv4 as an engine of business growth will be materially worse off when the well runs dry, the guys who have none now will be entirely reliant on secondary and tertiary mechanisms, notice I didn't say markets, for the assignment of address space. So the logical place to get address space, if you're a new entrant in this marketplace and you can't get some from an RAR, is to get some from a provider. And that is where a lot of people get address space from today. So I expect that will be the default route for a lot of entrants in the future. So today you can still get it from RARs. It comes from PA space. Transfer markets exist to some extent. And in terms of securing address space, one of the things that we assumed was really hard before has to be feasible for you now, which is renumbering. Because if you're moving between cloud providers, your security associations better not be a bunch of static bindings that you've put in firewalls some places, because you're going to have to change them all, and you may have to do that rather frequently. So in terms of address requirements, and this goes to if you were making a justification for ARIN or actually trying to figure out how many IPs you actually need. It's not just box count or IPs sitting on load balancers that show up in address requests. Outgoing NAT pools drive a non-zero chunk of your addressing requirements. Do your reaggregation for regional data centers, because probably you don't just deploy one. Drive the minimum prefix size you can get away with, and how many you need. And the mechanics of rejiggering prefix usage in order to move denial of service targets around or peel them off into third-party providers require some thought as far as address allocation. So the meat of this, REST APIs and the DNS and the grim meat hook future of NAT overload. So this gets to this carrier grade NAT problem. If you are a residential services ISP and you deploy a carrier grade NAT, if that device is a product of your design, is doing overload, that is, it's using a single or very small number of IPs as the source for outgoing connections, you're going to notice that a lot of your customers are hitting the exact same websites, which have a small number of IPs associated with them. Most of those websites are actually aware of this, and so they have enough IPs that your pool of source port numbers is not going to be rapidly exhausted. But in the context of internet content providers, if you are using a third-party API somewhere, you may have tens of thousands of machines located in the cloud or data center traversing an outgoing NAT box, which then hit a very small number of destination IPs on the other side. So that can become a problem almost immediately. And so one of the things that happened to me in the ITF context was PCP and port-controlled NATs of varying varieties caused me a lot of cognitive dissonance because the number of ports that has to be associated with a given host in my or someone else's network can be rather high if there's a very small number of destinations absorbing a large number of connections. So an example of this, if a destination address, let's call it Facebook, receives a few hundred connections per second and has a few hundred outstanding connections and 4,000 closed ports in time wait, don't we all love story problems, the probability of a naive NAT implementation reusing a port before it's closed and clobbering a new outgoing connection as a result is greater than 1 in 16. So if I have an overload NAT using one source IP, I have 64,000 ports available for that one IP destination. And so a certain number of the ports are closed, but still listening. And so if I happen to hit one of those, I send a SYN, and I get an ACK back instead of getting a SYN-ACK. And so I send a reset, and all of a sudden the TCP connection that would have been completed in milliseconds takes several attempts. And so if you do that on a large scale, it starts to hurt. And if I said to part of my organization, oh, by the way, 2% of your outgoing TCP connections are going to fail, and that's just reality, well, I don't think that would go over very well. Yes. So what do you do about that? So this is a NAT overload problem. Use a non-overload pool NAT for a supply of outgoing port numbers. So if you say, I'm going to have a port number for every outgoing connection I make, all of a sudden I need 16 IP addresses for every million port numbers that I need. That starts to factor rather quickly into the number of IP addresses that I need to assign as a content provider to a data center or to a given outbound NAT pool. What I would say is do not use brute force to solve an engineering problem. One of the things to do, if it's your API and it's out living in the cloud, bring it in-house or connect it via a private cloud so that it no longer traverses your stateful NAT box. So that's two wins. It no longer accumulates state anywhere, and it's not sitting on a big, expensive piece of hardware that has to hold all these port numbers. Encourage that app developer to use connection pooling and or reuse. So if that dramatically reduces the connection rate for your REST API, then hey, everybody wins. Another thing you can do is actually invert the relationship you have with that target. So a new target is created on your own load balancer pool, and you reuse the public IPs that you have that are associated with your load balancers as the source for the outgoing connections. So you've essentially doubled up on the use of IP addresses. So economies of scale, performance improvements, and faster servers contribute to a steady rise in the port demand for a given server count. Occasionally, like when you come up with an engineering solution to this, you get a drastic improvement in the number of ports that you consume. So that's I can stop buying a bigger NAT box and actually figure out how to make my app run better. So that clearly is a win. When other large-scale NAT applications face this problem, particularly with hot destinations, port-controlled or deterministic NAT mappings may help. And so there's a lot of work that's being done on this in the service provider space. People see this as feasible. So if they get a 2-to-1 or 4-to-1 or 8-to-1 compression ratio on the number of hosts per IP address, so for example, a host gets 32,000 port numbers statically or 16,000 port numbers or 8,000, that may work for their hosts. In the context of a data center where the source IP may be an incredibly hot box, by comparison, that may not work. The combination of overload plus pool NAT, which is the sort of scary full cone NAT where every single connection gets a new IP address, can ameliorate, if not entirely alleviate, this problem. So you may actually still, with a particularly hot destination, run into collisions on ports with some degree of frequency. That's going to depend on the total number of connections. It breaks applications that you're used to having work. So FTP PASV creates another outgoing connection. When it comes from a different IP address than the original connection, well, it doesn't work. So some assumptions that even applications that are generally considered safe for NAT traversal may not work in that context. So scaling-wise, it turns out that by now, vendors can build boxes that actually do 4 million NAT sessions per second. So it may not actually be volume of connections that's the problem. You may still have to spread these things around horizontally. And when you do spread them out horizontally, it turns out that if you do that in a stateless fashion, that each one of those NAT boxes probably requires its own address pool. And so at that point, when you get to the question of fault tolerance, the device that may have had 16 or 32 IP addresses allocated to it may turn into 3 boxes in a row, or 4 or 6, each with 16 IP addresses allocated to it. So there's the question internally to your network, how do you steer traffic into those boxes? It could be that your NAT translators advertise default and you do layer 3 ECMP to them. That would be essentially degenerate anycast inside your data center, which you may have much more deterministic control over than you would on the internet as a whole. You might use policy-based routing or flow-based forwarding to steer some traffic into one pool and some traffic into another. And in fact, in either case, that actually doesn't require that the NAT box itself know anything about this activity, but certainly some router in your network has to. Each one of those has attendant liabilities and compromises. If your L3 plus L4 hash isn't that sticky, it may be that you delete one member and all of your connections rehash across the existing hosts, everything goes out of state, and your network blows up briefly and then gets better. And that's probably not considered very desirable. What can IPv6 do for you today, especially in that context? So far, most of the visible efforts I've seen in the internet content provider space are user-accessible versions of services made available via IPv6. There are other less visible exercises, but a lot of what you see is IPv6 YouTube, IPv6 Google Search, IPv6 Facebook, IPv6 Zynga forums, et cetera, et cetera. In the scheme of things, making a service available to a small number of customers is not a particularly hard challenge. So if 0.3% of my users come in via IPv6, I don't really have a scalability problem to address in turning up an IPv6 service. My biggest concern ultimately is not breaking the IPv4 ones by turning that on. In the absence of a big inflow of customers, it's mostly about readiness and developing operational competency with IPv6. So on the other hand, exposing public APIs via v6 has a lot of potential upside that I can see. Even if the backends that are deployed are not fully v6 enabled, stateless NAT46 could be used to move that workload away from IPv4 NAT. So that's, even if I don't IPv6 enable the interior of my data center, I could still move that traffic from a stateful NAT translation to a stateless one if the destination was available via IPv6. And one observation to make there is, while I have the same port number problem, ultimately if there's a single IPv6 address used as the destination, it's relatively easy to add more v6 addresses to a load balancer pool, right? So once you've got one subnet deployed, notwithstanding any other considerations, you can add a couple more addresses onto that pool, put them in the DNS, or selectively serve them up, and that'll work just peachy. So pools of source port numbers become a lot easier to manage when you have an address per internal host binding. In the context of IPv6 and IPv6 enabled data centers, I imagine that for the most part, internal to outgoing connections, and so I differentiate these from external connections targeting internal resources. External connections targeting internal resources land on load balancers or devices like them on the border of my network. Internal to outgoing connections in the IPv6 context will continue to pass through a stateful device even as reliance on IPv4 NAT declines in the IPv6 context. So there will probably still be a stateful inspection firewall or similar device handling outgoing connections even if it's doing no NAT translation. Doing so maintains the posture associated with unsolicited incoming connections to internal resources. So that protects against certain kinds of DOS, for example, blasting neighbor discovery to internal subnets. Otherwise, it has the same considerations as any other firewall application. So it still has to scale. I don't see, in the context of a cloud or even my data center full of web applications, that I would be that concerned about exposing the internal IP addresses. We know they're all from my pool because we're not going to use ULA for that. But certainly we don't want those devices just receiving connections from random places on the internet. So the unsolicited incoming connections are expected to terminate on the equipment that accepts unsolicited incoming connections, and all outgoing connections can be made through a stateful device. So in my survey of cloud providers, today they don't seem to be entirely prepared to handle IPv6 internally. Some of them can do it externally. Amazon, for example, can do it in at least 2 different locations, but not all of them. What I see in terms of private cloud offerings is very large data centers plus multiple tenants plus private cloud interconnects equals VRF and more NAT. So if you're building out into more than one cloud provider, address space collisions are inevitable. Varying private clouds are separated via VRF, and you end up with stateful translation even to get into between various private clouds. So on that cheery note, we've been working under conditions of IPv4 scarcity for most of the commercial life of the internet. So it's going to get more so before it gets better. I do see some of the work that we can do with V6 is quite hopeful. We should be concerned about the costs borne by new entrants. The innovation disruption cycle that has allowed the internet to thrive, created lots of new value and so forth, may find it more challenging and capital intensive than previously. So we see in some businesses like semiconductors that every subsequent generation, while the end product that they produce may be cheaper, the process itself becomes more capital intensive as it scales. I think it would be unfortunate if that were to happen to internet innovation. So in some respects, I think that's one of my chief concerns. It's not that this becomes a little harder. It's that the whole process of doing it becomes more expensive. So that's me. And we are right at 17:52. So we have 8 minutes left in the schedule.
So can I show a slide with on FTP passive command?
Yep.
Yeah. Again, with static NAT, it is just a configuration error to assign different IP addresses to a single host.
Yeah.
Okay.
So that's true. And in the context of even pool NAT overload, if my device is smart enough, it can assure that the PAS-V connection that's associated with it gets the
doing
same IP.
doing it dynamic is somewhat impossible. It's difficult. Another point is that with just a single port forwarding state, a server can accept millions or billions of incoming connections.
Correct.
You don't need more state. And as a client, if you modify your application a little to use socket option of reuse port, you can connect to millions or billions servers from the client using just a single port forwarding state. Okay? So you don't need much port numbers.
Thank you.
So we had discussed for IPv4 conservation SRV records, which I think is great because why only use well-known ports, right?
Right.
And
so obviously, like what we're talking about here is, hey, 80 and 443 on all these machines are burned, but not any of the other ports.
Yeah, for servers, we're talking about content side, right?
Yep.
I don't know if it'll ever happen, if we're ever going to see wide deployment, because now you're talking about, lots of browsers or lots of resolver libraries. But another option for more with less, of course, is SNI, server name indication, for SSL, for name-based SSL certificates, which seems to work great as long as you're not trying to run Windows XP and IE. And I don't know why Microsoft won't patch that.
Well, I think you do know why they won't patch that, because that stuff's not getting patched, at least not the old stuff. But I mean, I think one of the interesting sandboxes that we all get to play in as content providers is mobile applications, which while I'm not entirely in favor of the balkanization of designing an app simply for the iPad or the iPhone or Android, I'm not entirely in favor of what that does to what we think of as the internet. Those apps are HTML5 plus, local APIs on the device. So if you want to use a different port number to do HTML5 driven connections to your load balancers, there's no particular reason why those have to land on port 80.
Right, that's true. And then I just wanted to lend credence. You had a slide in there about providers canceling customers to reclaim IPs. I believe that's what it was.
Yeah. So there have been reports both on NANOG and elsewhere of providers who have customers who have existing circuits that they've had for a very long time who found it economically interesting to recover those IP addresses by eliminating that circuit. So for example, if you have a /20 and you have a T1 with some legacy carrier, that may not be a service that they're interested in providing forever. It's entirely possible that they may not be interested in providing frame relay forever as well. So they can probably find a better reason than we'd like your IPv4 addresses back in order to get rid of that. But
well, I just wanted to lend credence to that. So we've actually, unfortunately, we've had to send cancellation letters to 20 customers this month in order to reclaim 2,400 IP addresses. Just not that they were using that many, but because they were peppered across all these little /24s that we otherwise couldn't use because they weren't a part of a legacy network. And yeah, we looked at it and said, you know what, these 20 legacy customers that have one server are not worth it. I mean, they can get new IPs, they don't have to go away, but we have to take those IPs
This
back.
is a line of business that we can no longer support.
Exactly.
Yeah, so when I was part of a business that was sold to another entity, a /19 of address space and a DS3 that had been originally provisioned by a company that became part of level 3 were tied up in that. And obviously the address space had existed for quite some time, and it was very painful for that organization to renumber out of it, which is why the DS3 continued to exist for nearly a decade. Even at mid-90s pricing for said transit circuit. But the acquiring party was obviously not interested in paying for that, and so that got ditched rather hurriedly at that point. But I would imagine that there is a lot of address space tied up in people's various legacy networks associated with services like that. And what is the economic value of a /19 when you have new transit customers to turn up who want /29s or /28s versus that one customer that's sitting on a big block?